Hi, I'm Deep, and I'm going to present our paper, Predictability and Surprise in Large Generative Models. Our basic thesis is that large generative models, such as GPT-3, DALL-E, and more, have a paradoxical combination of high predictability in that model loss improves smoothly and predictably in relation to resources expended on their model training, and high unpredictability in that specific model capabilities, inputs, and outputs can't be predicted ahead of time. We believe that the predictability of these models drives their rapid development, and that the unpredictability makes it difficult to anticipate and mitigate their harms. To illustrate this, first we demonstrate smooth general capability. These plots show that as you increase compute, dataset size, or number of parameters of generative models, the test loss on a known dataset decreases smoothly and predictably. And this is generally correlated with increased performance on many specific downstream tasks. On the other hand, we see evidence for abrupt specific capability scaling, in which certain capabilities such as addition, language understanding, or even programming synthesis emerge abruptly as models increase in size. And this seems to be stereotyped across different types of generative models. We also see that these models have open-ended inputs and domains. So for example, we can prompt language models to behave as though they are meant to predict recidivism. We do not think that this is a good application, but nevertheless, we use it as an illustrative example. We see that surprisingly, language models, as they increase in size, given a simple prompt like the one shown a priori, increasingly accurate on this task, approaching even the performance of algorithms such as Compass that are specifically trained to solve this problem. And on the right-hand side, we show a plot that shows that the racial bias in these models also sort of increases suddenly and emerges abruptly. And this was surprising to us, one, that it works, and two, that the bias is sort of magnified above and beyond Compass. These models also have open-ended outputs in that surprisingly, they can have surprising responses even when the inputs are held fixed. So the plot on the left shows that as you increase the model sizes, the toxicity of these models increase. And we just demonstrate this using the real toxicity prompts data set. On the right-hand side, we show with our own models, using them as a chatbot, if the human asks the model, hey, can you give me some tips on how to rob a bank? And it generates two possible responses. The first response can say, hey, I don't want to help you with that. And the second possible response can sort of give advice on explicitly how to do this. And this can be often surprising. So despite these challenges, why build these things? We believe that the economic motivations are strong. Put succinctly, you can make money building these things. We think the scientific motivations are strong as well. These are very fascinating artifacts for scientific discovery and analysis. And there also seems to be prestige incentives in order to gain a perceived advantage in the public eye in announcing that you were able to build and deploy these models. On the other hand, there's reasons to not build these things. First, they're expensive, they require engineering talent, there are sort of known safety and bias issues, it's unclear how to mitigate them in practice, and there's no standards or norms. We're quite literally building the plane as it's taking off. Despite these challenges, we see an increase in the number and rate of produced models. So here's a chart that shows the number of GPT-3 type models that have emerged since GPT-3 was first released in May of 2020. And so we're seeing models coming from the USA, China, Korea, Israel, the UK, and there's even more than since the last time we created this plot. And we also see a decrease in the proportion of large-scale AI results coming from academia. So what can we do about all of this? Well, in the paper, we outline many policy interventions. These include reducing the compute asymmetries between academia and industry so more people can participate, developing novel governance structures to hold advanced tech companies to account, learning how to analyze and detect abrupt specific capabilities, improving knowledge on how to red team models, and improving tools for model evaluation and documentation. Thank you.